Okay, it's working. Number 4, it says if Vx is 6.8 units and Vy is negative 7.4 units, determine the magnitude and direction of V. So let's draw a picture here. So what is it? Vx is 6.8. Vy is negative 7.4 units. That means if we draw an xy coordinate system, Vx is, I don't know, somewhere over there, and Vy is somewhere down there, and we're trying to solve that. I'm just going to call it VR. Okay? You see it okay?
Is it like a triangle? I can't.
Yeah, it's like a triangle. I'll put this whole thing on YouTube here in a few minutes, okay? When I get done, if you're having trouble seeing it, so you can just listen as we talk through it. So Vx is how far it goes in the x direction. Vy is how far it goes in the y direction, and Vr is from the origin to the far point. So they want to know the magnitude and direction of this Vr value. And so really all we have to do is solve the Pythagorean theorem. So Vr is equal to the square root of Vx squared plus Vy squared. So Vr is 6.8 squared. You see it all right? Okay. If you can't, tell me to get out of the way. Okay, plus negative 7.4 squared. If you solve that, does somebody have it?
101.
How much?
101, I think.
Did you take the square root of it?
Oh, no. Square root is, it's 10.05 once you take the square root.
Okay, so I'm going to call it 10.1. So the length of this vector is 10.1. Whatever, units is what they say. Then they also want you to find the angle. The angle will be this right here. So we can say, here's the equation for the angle. Tangent of theta is equal to Vy over Vx, where tangent of theta is equal to negative 7.4 over 6.8. I'm not going to worry about the negative sign. I know it's in quadrant 4 because of how it's set up. So 7.4 divided by 6.8. Take the inverse tangent of that. I messed it up. And you get 47 degrees. So theta is 47 degrees. So this angle here is 47 degrees off the x-axis. Okay?
And this is a lot easier to get here.
Yeah. It's what? I couldn't hear you.
Negative 47.
Well, I just said 47 degrees. I drew the picture. So I'm saying that this is 47. Maybe I should be more specific and say 47 degrees below positive x. Below the positive x-axis. Okay, that would be more specific. If you called it negative 47, Zach, that's okay. All right, same thing. So that's 4. Can I go on to number 5? You guys have any questions on 4? Okay, so let's go on to number 5. You guys are all okay too, right? So just speak up. We're trying to keep it all together. Number 5, it says graphically, which I told you don't do it graphically. We're going to do it algebraically. Graphically or algebraically determine the resultant of the following 3 vectors, 3 vector displacements. And so the tough part on number 5 is going to be drawing the picture correctly. Then we're going to break it down into components. So let me draw the picture. Hopefully you guys can see it okay. If you can't see it now, you'll be able to see it on YouTube. So I'm going to erase all this. And that's not erasing very good, but So you guys help me make sure I do this right, okay? It says 34 meters, 25 degrees north of east. So 25 degrees. So here's the first one. That's 25 degrees north of east. And how many meters did it say?
34.
34 meters.
Why does it say north of east?
Just because it's going above east.
Right?
Okay.
So it said north.
Yeah, so it's just going above east, so that's north of east. The next vector is 48 meters, 33 degrees north of east. So I'm going to redraw my XY coordinate system. Draw a new line. We'll say that's 33 degrees. And the length is 48 meters.
This one's east of north, not north of east.
Oh, it's east of north, is that what it says? Thanks for keeping me on track. So, I'm just gonna do this.
Frick.
This one is east of north. I read it wrong. So, 48 meters. That's 33 degrees. And I don't really want to use east of north, so what's 90 minus 33?
57.
57. So this is 57 degrees is what I'm going to use instead of 33. So I'm going to get rid of that 33. Then the last one is 22 meters at 56 degrees west of south. So 56 degrees west of south. I don't know, it's gonna be somewhere in here. What's 90 minus 56? 34. So that's gonna be 34 degrees off the x-axis, which is the angle that we want. And the length is 22 meters. So you have this weird path that's being taken, and we want to know what the result is, which is this right here. And so I'm going to set this up just like we did yesterday. I'm going to make a table here, and I'm going to put the x components here, the y components here. Here's the equation. Vx is equal to v times the cosine of theta. Vy is equal to v times the sine of theta. And I'm going to call this one vector 1, vector 2, and vector 3, just the order that we put them in there. So 1, 2, and 3. Okay, so let's solve all of them. The first one is going to be 34 times the cosine of 25, and 34 times the sine of 25. And I'll worry about, I'm going to go back later on and put the signs in it before we solve them. Then vector 2 is 48 times the cosine of 57, 48 times the sine of 57. And then vector 3 is 22 times the cosine of 34, and 22 times the sine of 34. We know that the first two vectors are going up and to the right, and so their components are going to be positive in the y and the x. The third vector is going down to the left, so it's going to be negative in the x and negative in the y. So I always go back and put my signs in, that way I don't have to deal with weird angles. You could change all the angles if you wanted to, but I'd rather just do it like this, okay? And so let's go through and solve all the components. So 34 times the cosine of 25 is 30.8. The next one, 34 times the sine of 25 is 14.4. 48 times the cosine of 57 is 26.1. Then 48 times the sine of 57 is 40.3. Then 22 times the cosine of 34 is 18.2. And then 22 times the sine of 34 is 12.3.
So how do we know when we need to find the components?
Well, anytime you're gonna find you've got more than one thing that you're gonna combine into one, you need to find the components. Okay, so we have 1, 2, 3 vectors
Yeah.
that we're trying to turn into one vector.
Okay.
Okay, so you definitely need to go through and find the different components of that. So let's add them all together, all the x and all the y's. And so we get a total in the x and total in the y, and we turn into one big right triangle is what we've done. Okay,
Okay,
So-
I've got a question for you.
yeah,
So on
Somebody add
vector
those up.
2, on the vector 2, since you changed the degree to being north of the east, wouldn't you have to change the sine and cosine around?
no, what I did, north of, when they tell you that it's east of north, they're telling you that it's off the y-axis.
Yeah.
So if you use 33 degrees east of north, you'd have to use sine in the x direction and cosine in the y direction. With that angle.
That's what you're about.
Yeah, so I went ahead and made it off the x, and that's what I'm gonna do basically this entire semester, is we're gonna deal with the angle off the x-axis. So you don't get confused about whether we're using sine or cosine, okay? Because the sine of, the cosine of 57 is the same as the sine of 33. Okay? Does that make sense?
Yeah.
Okay. So anybody have these added up yet? What's the x?
38.7.
Okay. And I don't know what the units are. Is it meters? Is that what it is? Yeah. So all the x components add up to 38.7 meters, and the y components add up to
42.4.
42.4 meters. And so what we've done is we've taken these three vectors and turned them into one right triangle. Okay, so in other words, this vector here, I'm going to redraw it.
Yeah.
Okay, so this vector here, which I can't draw straight lines. Okay, bear with me. Okay, goes 38.7 meters of the x and 42.4 meters of the y.
So that's, okay.
And so that's what we found.
Okay.
We've made it into a big or a small, I don't know, right triangle. And so now we can use the Pythagorean theorem, and we can plug this in for x, this in for y. So we can say VR, which is what we're trying to find, is equal to Vx squared plus Vy squared, the square root of that. So VR is equal to 38.7 squared plus 42.4 squared. And
How do you get the 36.7? What do you add?
it's 38.7.
Yeah, how do you get 38.7?
You add all the x components that we calculated together.
Was one negative?
Yeah, the third one is negative 18.2. Okay? Same thing in the y direction, the third one is negative 12.3.
Yeah, this makes a lot more sense. now.
Okay? So what's the resultant then? Anybody have that?
57.4.
Okay.
57 meters.
Yeah, 57.4 meters. And then let's figure out the angle. I don't know if it says to. It says graphically determine it. So we're going to go ahead and figure out the angle too. So we'll say tangent of theta is equal to Vy over Vx, or tangent of theta is equal to 42.4 over 38.7. If you solve for theta,
1.1.
that's it, 1.1?
I think so. Yeah,
Should
40,
47.6.
47.6? Okay.
Did you get 57?
Yeah. Did you do the inverse tangent of it, Carson?
Oh, no. That's
Wait,
what
so
I got.
do you-
I got 47.6.
Do you always use the the components for that?
Yeah. Yep.
So wait, what did you do for the tan theta?
Okay, it just says tangent theta is equal to Vy over Vx. So we're gonna take our y component, 42.4, and divide by our x component, 38.7. Okay, that's gonna give you a decimal. No, it gives you 1.1. And you just take the inverse tangent of that.
Yeah,
And that should give you, and I just lost
You
my.
just have to hit second tangent and then.
47, 46 degree.
Yep. I don't know if I could roll or not.
You have to say direction.
Well, since it's off the x-axis, I'm just gonna leave it like that. That would be 47.6 degrees, and I'll move it down so you can see it. Yes, it's a little bit. No, just leave it like that. You can put above the positive x-axis if you want to. But that's why it's important to have a good picture.
I'm so confused when you got 47.6. Is it, okay, so the inverse tangent, isn't that the?
That's second tangent.
And then
So it's,
just
maybe
put that-
are you in radians?
Probably. Yeah, that might be it.
So 1.1, so second tangent. Yeah, I think you're in radians.
Okay.
So put it in degrees.
Yeah.
So
Okay.
for tomorrow, or for Monday, you need to answer, let's do problems 6 through 9. Okay? You want me to leave the Zoom meeting up and you guys can talk?
I'm fine, I don't need it, but
Okay,
yeah, I'm good.
okay. You good with that, Zach? I'll turn it off. Okay, so I'm gonna end this meeting. If you couldn't see my stuff very well, I'll put it on YouTube here in a second and I'll just attach it to the announcements.
Good.
No, I'll get one of the 6 through 9 ones. Okay? All right, I'll see you guys on Monday, either here or on Zoom.
All right.
Take care.